Hey everybody, I wanted to show kind of really quick, go over the stack. And this is filled like, just think of this as a kind of like a maybe a recap or summary. So this is our Prometheus, and I'm not gonna talk too much on this video, just gonna stick to like checking some things out. So there's looks like it's not opening this endpoint. Go back to the query and run some queries in here, and this is actually running on my local host, guys. So you can't see the top of the browser, but this is localhost. And so target health basically shows my FastAPI endpoint. It shows us healthy, while the Ollama and Chroma are failing. I have to make more kind of fixes to that. And so let's go back to the code. So we have a Docker Compose file. Docker Compose file here splits our work. The reason I'm doing this video again is just to show you the whole part of this, how it's working together. So this is our API. Docker Compose basically builds our API with this Docker file right here. And this Docker file here has multiple stages, as I mentioned in the previous videos. We're using Python as a base image. And if we come here, there's a couple of environment variables. The model is phi3, and Ollama. Chroma depends on two basically additional services, which is Ollama and then Chroma. Restart on failure. Image it's using here, you can see there's no Docker image for the Ollama I have in Docker Compose. I'm just using the pulling from the the Docker Hub, the latest Ollama latest, and so that's using that. There's another environment variable, Mistral and phi3. It's basically using so one thing to note is that our API is using the model phi3. For the Ollama, it downloads two models, Mistral and phi3. So it's it's basically like a kind of it's like Ollama as a like inference, like the AI serving service. It's basically what it's doing is that it has two models, but the AI the API app that we have, it's using only this model right here. All right, so entry point, there's a small script I did, had to do a little bit of duct taping because I was running some into errors and stuff. Waiting for Ollama server to start Ollama and server in background, wait for Ollama server to start, download the models, and wait for Ollama server to process to exit. Then go back to Docker Compose again. This is Chroma, the vector database we have. Same thing, I don't have a separate Docker file for this, and that is Chroma is right here. So this is our Chroma container. So let's go back to the Curo. By the way, I'm using Curo, the IDE that I've talked about before. Pretty handy. It's very useful. So what is Docker Compose and why it's better for local development than K8? Let's do that. I'm just gonna run that. And while it answers that, we're gonna do, we can see it's just answering some answers in here. So Prometheus, we have another service here for Prometheus, and Prometheus basically uses the same thing, its own image. There's a volume for Prometheus. It's I believe, yeah, it uses basically the volume, attached volume, is because of the file, so we're adding that file in there, the Prometheus file. We have the Prometheus file here, and Prometheus is basically, we're using it as a source for our Grafana, and Grafana is right here. It's basically, as I mentioned, it's a great visualization tool. God, this is so hard to say. Basically, it's a tool that uses data from different data sources and makes a nice graph that you can interact with. God, it's crazy hard, this word thing. And Prometheus is basically a monitoring system that that collects and stores metrics from various sources. Grafana is really great for metrics, logs. You can query, Grafana queries the data source, and data source returns the response. So yeah, it's part of our observability stack. FastAPI dashboard. This is actually one of the dashboards that I made for the Grafana in JSON. This is an additional documentation. This is the app right here, the FastAPI app. You can see the modules we're downloading, Pydantic. We're using FastAPI, ChromaDB, because you guys remember we're adding this data right into our Chroma database. So it has to load the data to the database as well. Now let's quickly go back to the containers. Check out the containers and our services. This is the API. This is Grafana. Let's check out the logs for Grafana. Succeeded, clean up. And then let's go back to Prometheus. Prometheus is here. And RAG, I mentioned about the RAG before. RAG is how we make AI smarter and more factual. And then Chroma is right here. I think I've shared the screen for this is Prometheus and this is Grafana right here. I showed in the previous videos, right, where the request that we did these requests basically with a curl, ask financial advisor endpoint and generate endpoint. And then if we go back to, this is more of a hands-on part, guys. Chroma, and then we have Ollama. Ollama is basically our, it serves our AI model, and where the RAG basically kind of combines the answers. And normal AI like ChatGPT, for example, answers from what it was trained on, while Ollama, it was trained on, it might know your company, it might not know your company data. So that's part of the reason we use RAG, because RAG, basically what we're doing here is we're loading the database, the vector database, with our additional information, and then making so that LLM doesn't hallucinate and uses the latest information. So for example, the latest wiki updates for our company, the LLMs don't know that, right? So the public Llama, or like Mistral in this case, where we're using Mistral, right? So if we go back to our, in this code here, if we go back to Docker Compose, you guys saw that I'm downloading Mistral, right? So let's say if I use Mistral, Mistral doesn't know that I'm using what kind of information my company has. So in order for it to understand that, I need to use a RAG. I need to build a vector database, connect that to our AI agent, and then it will be able to kind of combine those two responses. So retrieves, RAG is basically adds a kind of like a memory booster, think of it that way. It retrieves the info from your own data, which is stored in a vector database, augment the AI's answer with that information, and then generate more accurate, up-to-date response, more relevant in context. Sorry. So we ask, what is our refund? For example, if we're a store, we ask, what is our refund policy? And then AI doesn't know that by itself, right? So how does it know? It's not like, it doesn't, let's say if we're a new store and it wasn't trained on. So that's where it comes in handy. So what the RAG does is that it looks into our company store wikis, finds the right information, gives it to the AI, and then AI answers correctly instead of just making up some stuff randomly. So yeah, I just wanted to quickly go over this stuff, and this document, guys, you will see it in my posts. Please check out the posts. This is the project number 3, version 1 document, and sometimes you guys will be seeing that I post version 1, version 2. Just try to see what the differences are, but in this case there's only one version for this document here. Please follow and subscribe, and hopefully this was helpful. I really appreciate it, and thank you. Have a good one.